Alright, so we're still finding end behavior models. Find end behavior model. But this is when we've got not a polynomial over a polynomial. So let's say I want to find a right and left end behavior model for f of x equals x plus cosine x. Okay, I'm going to do a few examples. So if it's confusing after one example, hopefully a couple more might help out. So we want to find a right end behavior model and left end behavior model of x plus cosine x. So for the right end behavior model, so as x goes to infinity, what's the best representation? And then for the left one, as x goes to negative infinity. Okay, and just like I said, one example is not enough because they're all a little bit different. Okay, so the good news is it's going to be either that or that. The answer is either going to be x or cosine x. Okay, so think of what x looks like. Well, y equals x is just a line, looks like this. So it does go to infinity as x goes to infinity. And as x goes to negative infinity, it goes down to negative infinity. Okay, cosine x. Well, that just keeps chilling between negative 1 and 1. Between negative 1 and 1. So it never gets powerful. It never becomes a dominant function. It just chills between negative 1 and 1. Okay, so that's an indicator right now that it's probably not going to be an end behavior model. Like x plus cosine x, what's going to be the most powerful? Well, x is going to become infinity plus some number between negative 1 and 1. Yeah. Thanks for your contribution, but you're really not giving us much there, cosine x. X is going to be the most powerful both to the right and left. That's kind of the logic that is going into it. Okay. So you could think of it as which goes farther away from the x-axis to the right and to the left. Well, it's clear that x is going to be the right end behavior model and the left end behavior model. Okay, so we know our answer. It's x and x. But let's prove it, and you're going to have to do this on the test and quiz. You're just going to have to support your answer by finding the limit as x goes to infinity, because it's to the right, of x plus cosine. So whatever we use our end behavior model, you have to get 1 for an answer. The limit has to become 1, which makes sense. This amount over its model, if they're the same basically as x goes to infinity, you should get something divided by itself should be 1. So is it going to be 1? So I'm going to choose the wrong one initially, just to show you that cosine x is not going to be the right end behavior model. So you take your original, that goes on top, and what we're choosing our model to be goes on the bottom. So we're comparing them, that over that. Well, since there's 2 terms on top and 1 on the bottom, we can separate them. So x over cosine x plus cosine x over x. Well, cosine x over x, that's just 1. So I have x over cosine x. So what is the limit of that as x goes to infinity? Well, what happens to an x? It becomes infinity over a number between negative 1 and 1. So really large over small. If there's more dominant terms on factors on top, then you'll always get infinity. This goes to infinity because there's a more dominant one on top. The higher one on top always goes to infinity. If the higher one was on the bottom, then it would go to 0. It's either infinity or 0. So I get infinity plus 1, which is infinity. Infinity plus 1 is infinity. Well, that is not 1, so we're sad. We chose the wrong one. We'll go back and squeeze in here. Limit of x plus cosine x over the correct answer as x goes to infinity. Separate them, x over x plus cosine x over x. This is 1, so 1 plus the limit as x cosine x goes cosine x over x as x goes to infinity. That's going to be a small over large. The more dominant one is on the bottom. So imagine a really big number. Cosine of 1,000,000 is somewhere between -1 over 1,000,000. 1 over 1,000,000 is a really small number, and it's only going to get closer and closer to 0. So you end up getting 1 for an answer. So that makes us happy. So our answer to the right is going to be x. The left in behavior model for this one, again, we're going to choose x, so the limit, and we're going to justify it, negative infinity of x plus cosine x. I'm actually going to choose correctly this time. So again, we separate them. This is 1 plus, as x gets to a negative infinity, you're going to get a negative between -1 and 1, which is small. This is going to be a really big negative number, but a small number, whether it's positive or negative, over a really big negative number is always going to be small over large is 0. So we get 1, which is what we wanted to get. So our left end behavior model is also x. All right, another example. How about a right end and left end behavior model for, we'll do 2 to the x plus 4x, something like that. Heck, we'll even do 4x squared. Well, we'll do 4x. Okay, so we need a right and left end behavior model. So we need to know how they behave. Well, 2 to the x is it's an exponential growth function, okay, which is really in the hierarchy of math equation. That's a really powerful one. 2 to the x goes to infinity fast. Okay, y equals 4x is a linear situation. Okay, it goes to infinity also, but it goes there at a linear pace. Exponential is going to go up faster than a linear situation. Okay, so as x goes to infinity, they both go to infinity. Which one goes away from the x-axis faster? That would be exponential growth, so 2 to the x. Okay, so that's going to be our right-end behavior model. And we can justify it. The limit of 2 to the x plus 4x over 2 to the x as x goes to infinity should be 1 if we chose correctly. So we get 2 to the x over 2 to the x plus 4x over 2 to the x. So that's 1 plus. Now, what happens? We've got 4x as x goes to infinity is large. I mean, that goes to infinity. But 2 to the x is really large. Okay, it's bigger than a linear relation. It's an exponential one. So the more dominant one is on the bottom. So even though the top goes to infinity, this quantity is going to end up becoming 0 because it's more dominant on the bottom. So 1 plus 0, we get 1. So our right-end behavior model is 2 to the x, and we proved it using our limit. The ratio has to be 1 in order for it to work. Find out which one's more dominant, and if it's on top, it goes to infinity. If it's on the bottom, it goes to 0. All right. Our left. So as we go to the left, at 2 to the x, you know, it's powerful in as x goes to infinity, but as x goes to negative infinity, it then approaches 0. So it gets really small. It doesn't have any dominance over any other function. It just goes to 0. Okay, the line is going to go to negative infinity at a linear pace. Okay, so it's going to definitely go away from the x-axis faster than this one, because this one actually is going toward the y, or toward the x-axis. Okay, so the line 4x is going to be our left-end behavior model, and x approaches negative infinity of 2 to the x plus 4x over 4x. Remember, it's going to negative infinity here, so we're doing 2 plus 4x. So that's 1 plus. Now 2 to the x over 4x. Now, before we said this is more dominant than that one, but that's only when we're approaching positive infinity. It goes away from the x-axis. We're approaching negative infinity, so this ends up becoming 0 over negative infinity. So this one, the 4x, goes away from the x-axis faster, so that's going to be more dominant. So if the more dominant one's on the bottom, you get 0. So we get 1, which we wanted. So our left-end behavior model is 4x in this case. And then we talk about how do you compare 2 to the x to 4x? Well, 2 to the x, it seems to be more dominant. But what if we were comparing 2 to the x to x cubed? Which one's more dominant? Well, if you graphed it, it may or may not be apparent. So y equals, clear that out, I've got 2 to the x, and then I've got an x cubed. I'll do I'll just start with a zoom standard. There's my exponential. Here comes my cubic. Okay, so it looks like the cubic is going to be more dominant because it's getting there faster. But if you zoom out, maybe I'll just increase my y max to 100, see if that does anything for us. Here's my exponential. Here comes my cubic. Okay, so it still looks like the cubic is more dominant. Will the exponential overcome the cubic? Let's find out. So window, and I've got only a couple minutes of this video because it cuts off at 15 minutes. So we'll go to 1,000. Oh, it's catching up. I'm going to have to increase my x max, let's say to 20, and I'll go to like 2,000 now. You know, the cubic had a really good start, but it's not going to win. So exponential is going to win. Exponential is pretty dang powerful in math. So that is more dominant. So the limit of 2 to the x over x cubed as x goes to infinity would be infinity, because that's more dominant and the more dominant one's on top. If I had it upside down, x cubed over 2 to the x as x goes to infinity, then this would be 0 because the more dominant one is on the bottom. Okay, so what about x to the 4th, x to the 5th, x to the 100th? What's more powerful? The answer is always exponential. Okay, if you're exponentially growing, it might take a really, really long time to overtake x to the 100th, but it eventually will. Okay, as long as it's exponential growth. Okay, so even if it was like 1.5 to the x, it doesn't grow as much, or 1.06, it's exponential growth, and eventually all exponentials will overtake any power function, even if that was x to the 1,000th.